Hello and welcome to this TopoDOT presentation for Lidar CANEX. Today, I'm going to go through the introduction for TopoDOT, show you a little bit about the tools and applications TopoDOT offers and how we can do project collaboration. So the point of this presentation is to show you a little bit more about how to leverage your point cloud projects for effective support of 3D design in construction process. So let's get going. My name is Jennifer Triana. I am the Business Development Director at TopoDOT. We are a small software company in Orlando, Florida. We have been in the LiDAR industry for a long time, started in hardware, and started developing software around needing more solutions for survey applications. And we have been developing TopoDOT for over 15 years. And it's now quite a larger organization. We have offices all around the world, and I handle sales for the Americas, so North America, South America, including Canada. As you can see, TopoDOT is being used by a wide range of organizations in the Americas. We have over 6,000 users and more than 630 customers all around the world. The majority of these are in the transportation market. TopoDOT is being used for quite a few organizations in government, such as City of Toronto, Manitoba, Calgary. And a lot of the people that cater to projects for the government in transportation are use TopoDOT quite a lot. And so you see here, maybe recognize some of the names of companies that you're familiar with that currently use TopoDOT. So it's not new, but just to make you aware of what is TopoDOT, it is an application for the Bentley platform. To be able to bring in all of these point cloud information and calibrated imagery associated with the point cloud into the CAD environment where you can extract and create topography models from this data. You would be able to extract highly productive models of relatively the features that you've been collecting for a long time, but now it's going to be at a higher detail, a much faster process. You'll have control over that process, and you can deliver all kinds of deliverables to the LineWare, 3D LineWare surface models, 3D models, indoor applications, and more we've been focusing on data analysis. So this is basically functions that doesn't require a lot of modeling, but analyze the data directly and create reports. So we'll discuss those as well. So let me tell you a little bit about why TopoDOT, what makes TopoDOT different than most other applications in the market for point cloud processing for feature extraction. So TopoDOT pretty much runs this section of the process that you see here in green. So before you even coming into TopoDOT, you have some process outside that collects data and adjusts it to adjust the data to control or to survey information. That process is still part of the system. It's at the system level, because at TopoDOT we don't know enough about what happened at the system level to adjust data around. So we don't actually move data. That has to be done before you're coming into TopoDOT. What we would help you do in TopoDOT is once this data is lined up or is being adjusted to the correct datum, you can bring it into TopoDOT for this process. We call it the MAX process, Manage, Assess, Extract. So with the Manage process, you will be able to handle quite a large data sets, combination of multiple systems. You name it, that your project could be as large as you want, and you still be able to handle the data easily for cloud storage and also for being able to share it amongst multiple people. Management also means that you can you don't have to clean up your data. So you never have to remove, filter, classify, merge, or do any kind of editing to your data. We will help you manage your data from the raw state that you have it when you collect it. Then we have tools for QA/QC, or a quality assessment, to ensure that your data is going to meet your project requirements. And then we give you all the tools for feature extraction as efficient as possible. Semi-automatic functions that are going to make your processing a lot faster, but also keeping control over the process. And then you have quality assessment of the model, so that you know that that model matches your point cloud, which the point cloud we know matches the control, and therefore keeping that lineage through the original survey, so that when you deliver this information, you know that it is going to meet your project requirements. And after this, you can export it anywhere you want to go. So if you want to be in Civil 3D or Autodesk products, if you want to go to ArcGIS, if you want to stay within the Bentley environment, MicroStation, OpenRose Designer, etc., maybe you want to take it to Carlson or to a publisher, whatever you need to do, you are in a CAD environment that you can use, where you can export this information quite easily. So that's the process itself. Let's talk about other things that make TopoDOT very unique. So for one, we never really have to clean up the data. So there is no need to spend a long time trying to remove noise, trying to edit your data and remove noise from your data, because we know that it is a process that is standard in the industry to try to classify and remove data. But why you don't need to do that in TopoDOT? Well, in TopoDOT, we focus on ignoring this information. So as you can see here in this example, we're extracting the road surface. Those are the blue dots that you see there on the ground. And as we create cross sections here, you can see that we have all kinds of noise from vehicles. And that is not disrupting the process of creating the points on the ground. On the contrary, you have it there, you see it, but it's not affecting the extraction. So there was no need to remove any of that information. Furthermore, TopoDOT focuses on key information. If you've ever brought in a DTM that was a little bit too heavy in Civil 3D, you'll know what I'm talking about. In TopoDOT, we focus on the key important information about your data. So you can be sure that you're just extracting what's necessary to make it as optimized as possible. One other important factor in TopoDOT is that we don't actually pick points out of the point cloud in order to make surface models, for example. All kinds of point clouds have different levels of data noise or thickness, the fuzziness of the data. In TopoDOT, instead of picking a point out of the point cloud, which could be that you're in the highest or lowest end of the noise spectrum, we instead analyze that data as a whole and place a point that best represents that surface. And because of that, we're cutting error by half. And so you can apply this concept to even the fuzziest data, to even the noisiest data. So this is an example of imagery-based data, so not LiDAR, just made from images. And it's very noisy because it hasn't been smoothed out, but you can still extract very clean models because noise is not an issue. So you can apply these processes to even the noisiest data. One other key factor is that we have the right level of atomization with the highest quality standards. So basically what it means is that you want to be able to have a tool that automatically extracts as much as possible, but where you have control over the process. So if at any point you want to verify a point, verify a cross-section, adjust anything at all, you have the ability to do that. Especially because not all, you can't scan something to death, right? Like there's going to be gaps, there's going to be areas where you have obstacles or obstructions, and so you're going to have gaps in your data, or maybe you're going to have noise, vegetation, water, all kinds of stuff that is going to disrupt the process. So TopoDOT is going to give you that option for you to, for example, in this case, you can see the cross-section here for the inlet. You can see where the points are being placed, but you can adapt it, you can change it as you see fit, based on what you're seeing, even if the points don't exist. So you can modify your feature extraction based on the user input. So you don't just have to work with what you have, but you can still make decisions around the feature extraction. We also have a ton of tools that will make your break line extraction a lot simpler. So in this case, for example, we have something called a smart cell, which is a template for features that happen in between your break lines that are constantly happening, like ramps, drain inlets, driveways. And with this template, basically, we just identify what's changing, right? Like what edges need to change, and those are the ones that we're going to move or adjust to current conditions. And that way, it doesn't take you minutes to create this whole drain inlet, but seconds to just apply it and adjust it to the current settings. So again, you have verification methods to ensure that everything is going to be draped properly at the right elevations, etc. So you're going to want to have some kind of process that is as automatic as possible, but that you can qualify as you go. Furthermore, we want to emphasize that TopoDOT is system neutral, so you can bring in data from any system and also combine data from different sources. As long as it's a point cloud, it can be brought in TopoDOT. In this example, our clients from Trek collected this data with a mobile scanner on the rail area, and over the cliff side, where the blind spot for the mobile data, they collected it with a UAV system, a drone system. And the data was using the same data, is relatively close. And when you bring it together, notice how it's not overlapping, but it is close. And when you process it as one. So this data fusion process is certainly very useful, and because the tools will work the same for mobile to drone to tripod-based scanning. There's going to be the same exact tools for for similar features from different data sources. You just need to change settings here and there, but you can apply it to different systems in the same platform using the same processes. So it is ideal for data fusion. So here I'm going to take a little second to introduce this next slide, because here we're going to talk about specifically road extractions, topography extraction. So I'm going to take you through how to extract a road project, topography project. This was collected with a tripod-based system or a static system, an RTC360, and we're going to take a look at this in the next 10 minutes of how do you go about extracting features from point clouds. So again, this process is duplicated is replicated in drone systems and mobile systems, imagery systems. The tools are going to be the same, basically. So what we concentrate on is a signature-based approach. So instead of just kind of cleaning up the data and creating a surface model, what we're doing is we're isolating or finding features that are specific, that have a specific signature. So in this case, paint stripes are meant to be highly reflective. They're part of the laser source. The intensity is part of the laser source, and something that we can isolate and identify quickly. So with that information, we can use that information to create these vectorize these paint stripes. So maybe you don't need the paint stripes, but you can use that information to create center line down the road and alignment down the road, or even just to create a line that is going to help you extract other features. In that same fashion, anything that has that intensity values that we can isolate, anything that's being painted on our road, has a specific tools for feature extraction. So you saw the zebra striping, but now we're looking at assets. So arrows or text or anything that is laid out on the road, you can automatically identify these features and not only create a symbol for them or display some visual characteristic, but you can also record it into a list that can be exported later as a ASCII file or a shape file with attributes. Now we're going to get into the break line extraction, and what you're seeing here is the automatic break line extraction. It's called the template tool. This is more than just template matching. This is actually identifying other other features for this curving. In this case, it's looking at tilt, it's looking at rotation, but it's also allowing you to qualify the results. You can see how the tool behaves on every cross section, and where you need to make changes, you can make changes on the fly. So when you're done, you are verified that your line work is proper, and you can move on. You don't have to go back and make any changes or update any issues, because you can create and verify at the same time. We also have some more controlled versions of these breaklines tools called the breakline extraction tool that will allow you to see every cross section at a time. That's especially useful for areas where you might have older sites with broken curves, with different templates, etc. Furthermore, we can show you more about like road extraction. We have so many tools, so many variations for the road extraction, for you to identify everything between just edge of pavement to ground, to slope changes, to the stress analysis on the surface of the road, for identifying like potholes or drainage issues, cracks, etc. Anything else that you might need to create break lines for using the draping tools is a very simple process. But here's another keynote, a key point for how TopoDOT works and how easy it is to create line work even when you don't have data. So in this gap of the sidewalk, we're using a little bit of the data in the concrete side that is visible to identify that elevation. So even if you don't have data around that break line, you can still sort of make it up using data that is close by. So not everything has to be scanned, or not everything has to be fully scanned if you have the right resources. That same tool can be applied in other situations. For example, here we have a ditch line, and we can just say, well, I need to find the lowest point automatically. So this tool will automatically find that lowest point, adjust it horizontally and vertically, and because it knows that it's grass, it's going to pick the absolute lowest point, so there is no averaging here. For those natural surfaces or ground extraction, we suggest to also add additional points, so ground extraction points, that are going to give it a lot more definition around the slopes and anything that changes around the ground. And again, you never have to clean up the data, you never have to remove vegetation or anything like that. When we're creating cross sections here, you see all the trees, but you also see how that mesh will go underneath and give you all that detail around the slope changes in the berms. If you need to do any utility mapping, power lines or communication wires, we have plenty of tools for vectorizing wires, for identifying clearances, for identifying utility poles, and not just to vectorize this information, but also to identify other features about the poles, for example. So in this case, what we did is we joined those wires, created those attachment points, and that creates this pole, or this utility pole, that you can later go in to create a cross section and identify further annotations or points within that pole. And again, everything is visual as text or clear or dimension or a solid model. But you can also annotate this as an attribute for you to export it later as an ASCII file. In this next example, we're seeing asset identification. So poles, posts, fire hydrants, anything that sticks up from the ground, you should be able to identify it and then label it. But the tool will identify it automatically out of the data, allowing you to just, move within that table, identify whether it is indeed a sign or a pole or a fire hydrant, and make any further annotations. So maybe you want to specify or add any kind of information about these features, for example, height, radius, elevation diagram, or maybe something that is more manual, more visual, like it needs maintenance, it's pointing north, it's an oak tree, or something like that. You can add all that information here as well to create a database of assets. So for this tool, it is It is an automatic tool that picks up all of these vertical assets as it goes. You can also use it for flat assets like manhole or utility covers, etc. Once you create all of these line work points and lines, you can export these features as, using the feature code export with the appropriate feature codes in the format that you might need for either Civil 3D or Carlson or anywhere else where you need to go. And this will give you like a readout. Or you can just save your MicroStation file, DWG file, DGM file, into DXF or DWG file for AutoCAD or Civil 3D. So the results are pretty easy process of feature extraction based on signature for those features, and in the end this is going to be very productive because you're checking at the same time as you're processing, so you never have to go back and find where there are potential issues, and that makes you very efficient. So for these 2 miles of road, you can complete it in hours. Okay, so that is the main process for road extraction, and so I can show you that same exact process on drone data or on mobile data using exactly the same tools. But I want to focus on other things that are new. So we have a new ground algorithm that is going to revolutionize the way that you do surface mapping, especially for those drone projects of bare earth areas. So our new ground extraction algorithm focuses on validating points a lot more automatically using AI. And therefore, you're not going to have so much cleanup, or maybe identified. You're not going to need to qualify so much the process, but just identify the correct settings and run it. As you can see, it's going to be very easy to create surfaces from these points, even on the rockiest terrain, ignoring all the vegetation and being able to extract just the surface in seconds. So this is going to help you create, so for example, in this query example, you're going to be able to create a surface that is very tight, very exact to what you would currently have break lines, but you don't need to create break lines because you're going to have points everywhere where you need it. And so that process can reduce your processing time by more than 1,000%. So basically what this process is going to be, and again, this is all actually coming out next month, so it's not even released, but this is how we're constantly trying to upgrade our tools. Usually when you do create ground extraction, it's going to be very easy to do on the relatively flat surfaces or even the small slopes, but when you have those more vertical features, the rock faces or the quarries and things like that, is where it gets sometimes difficult. So with this new tool, you're going to see that it does a much better job at identifying those vertical features without including actual vertical features like walls or buildings or poles, and still give you that very clean surface model to create your mesh. So we have tools for all kinds of applications. You can also see some examples here for the utility pole extraction that we saw a little bit before that. And I'm just going to skip this for now. Let's talk about the pavement condition analysis. This is something that is very popular. I've seen some case studies especially in Canada for creating an effective process of the quality of roads, for monitoring roads health for cities or towns. for periods of time, and to identify where the worst deterioration is happening and being able to concentrate in the worst areas at a time. So this process, as you can see, is very simple. It goes directly on the data. You don't have to extract much, but just the paint stripes, and this automatically identifies large distress types like shoving, puddling, etc., and creating reports that can be easily digested by anybody that is managing this road networks. So all of this is only possible through TopoDOT. But what's most important for your clients is going to be how you collaborate, how you share this information, how you store this data and reuse it constantly. So you can reach out to us and learn more about TopoShare, the web portal. In TopoShare web portal, you basically will need to create a warehouse, and this could be, it could be your storage. You could use whatever cloud storage you want to define, and in TopoShare is basically going to help you manage your project very easily, so that you can allocate your files depending on what you're trying to store, metadata, point clouds, imagery, control information, just anything that you want to add to your project. There is a bin for that, right? And as you're storing this information, it's going to be very easy to display what you have for that project, how to access it, what is the quality for my project, can I reuse this data for something else, for another purpose, etc. So when you are storing it in classifying all this information easily like that, it's very easy for anybody to access this information. They can go directly to the dashboard, the map, see what that project looks like, download it directly into TopoDOT, start using it right away, because it's very easy to access. So anybody that is using TopoDOT will be able to access this information quite quickly and start processing it directly. And for those stakeholders that they're not actively using it for TopoDOT, maybe they just want to see the state of the project, maybe create some work orders based on what they're seeing, you can just share a web link with that same information. In that way, the client can use just this web portal to identify what's the project status. They can see the point clouds, they can see the calibrated imagery, they can see the line work extracted, and it's all in this web portal. So they don't have to download any special data or any special software. They can just access this information directly here. So TopoShare Enterprise, which is this dashboard, will provide you the platform to share this information and to communicate with anybody internally or to your clients about your project status, and be able to collaborate in further development, further feature extraction, or just to update anybody about the status of your project. So I just want you to see a little bit about the imagery. So you can pull up this calibrated imagery. So this is ground-based LiDAR. This is using a mobile scanner. You can see that these images are not just pictures. They actually have depth information, so you can make simple measurements on them as well, and create work orders. So you can just kind of identify, anything that you might need to request or add. You can create work order requests directly here. So just to end this, I wanted to share my contact information. Please join us on our webinar tomorrow for further information, where we're going to go into actual examples. Appreciate your time, and please let me know if you have any questions. Thank you.
Oh, hi, Jennifer. Thank you very much. Jennifer and I both had challenges trying to get our video down to an appropriate time and size. There were a couple of questions that popped in. We have a very short time window before the break. However, I know Gasper was interested in whether NavViz product was ever used with your software. Do you know if any of your users have used that hardware?
Yeah, we have plenty of customers using NavViz data with TopoDOT, so it is certainly possible. Like I said, TopoDOT is system agnostic. So as long as it's a point cloud, you can bring it into TopoDOT and do any feature extraction. But I can certainly share with you some, examples of that.
Okay. And very quickly, another question was wondering if TopoDOT is only for outdoors or can it be used for indoor automatic extraction, floor plans, etc.?
Of course, yes. So I showed a very transportation centered example, but there are tools for almost anything that you might need. So indoor applications, of course, we have all kinds of tools, not just for modeling, but for data analysis, like for example, floor flatness or obstruction, identification, piping, stairs, all kinds of stuff.
Okay,